Methods of communication, presentation, and argumentation of research results, prepared by Frane Uren. In today's higher education, it is common to divide universities into those that are teacher-oriented and those that are research-oriented. However, research orientation is not essential for the quality of a higher education institution without a clear link between scientific research and teaching. Such an approach is recognized in the newer version of the standards and guidelines for quality assurance in the European higher education area, emphasizing that quality assurance policies are most effective when they reflect the relationship between research and learning and teaching. Various examples of good practices contribute to this goal, such as designing case studies based on which students can write a paper or conduct research, student participation in research projects, writing papers with students, etc. It is also essential to apply teaching methodologies derived from research by improving and adjusting course implementation plans and programs. In this part, older approaches to teaching are especially emphasized, such as problem-based learning and project-based learning, where students are usually presented with a task that they have to solve on their own needs in order to help them fill their gaps in knowledge or develop the skills they need to solve a given problem. Some authors go a step further and propose a research-based learning method called inquiry-based learning that builds on the two previous approaches because the student is given problems that require additional research to solve successfully. In such learning, the student additionally takes an active role and responsibility in the learning process. According to the EBL methodology, the student initially connects in detail or deeply with the teaching unit and the problems he or she must solve during the learning. Then he asks research questions and identifies various sources of knowledge on which one can find answers. Apart from classical sources of knowledge, such as textbooks, the student is encouraged to use sources that include locating high-quality information on the web, searching the books and electronic journal databases. The next step is to evaluate the collected information and its synthesis into a coherent whole. The final part of the research process is communicating what has been learned and how it is learned. The final part of the research process is communicating what has been learned and how it is learned. In order for this to be possible, students must have communication skills and scientific literacy skills. That is to say, they must be able to present data that form the basis of research and which must be shaped by way of thinking that led the research. In other words, it is about telling a story that was created based on discoveries but which has a given structure with the presentation of the obtained data and the discussion of the obtained findings. In doing so, formal language is used to state specific claims for which there is evidence, and cautiously formulates claims that may not be proven or the subject of future research. It is clear that the data are not available immediately since they needed to be collected, formatted, and analyzed after the research is completed. However, even before the data is processed, it is possible to imagine the structure of the future story, since the data from previous research was probably the motivation for the current research. In addition, interpreting the existing data is an excellent preparation to focus on the current research topic. Of course, The story must be coherent to connect previous knowledge and discoveries, but it is necessary to clearly say the content of previous research and theory and cite it correctly, what is new and why it is significant. When the data is finally collected and processed, there will probably be some noise and confusion among researchers because they have a large amount of information that needs to be interpreted meaningfully and at the same time interesting to someone who will read it. Recent psychological research suggests that the interpretation of research data is performed by the subconscious. One of the techniques that help in faster retrieval of the data processing from the subconscious is the technique of free writing. In doing so, the author freely and without corrections in a limited time interprets the data from the research using an ordinary pencil and paper. In the subsequent reading of such a text, the key points and statements that make up the summary and chapters of the scientific paper can be identified. This picture shows a case where the authors collected data on the experiences of students studying on an augmented reality platform. But while the research data had not yet been processed, they identified chapters of future paper with free writing techniques. Every scientific paper discusses the research results, but different scientific fields have different conventions and rules, even if similar research techniques collect the data. For example, a historical study of the Spanish flu pandemic conducted in the 1950s by interviewing survivors of the flu will differ significantly in its presentation from the presentation of some significant findings of the COVID-19 pandemic recently published in a medical journal. The reason is that different fields of science ask different questions about the same or similar things because they want to get different answers. In this case, historians will ask questions that will provide answers about social relations and how the pandemic started. But medical experts will be more interested in the clinical picture of the disease and treatment methods. It can be said that two methodologies, separately or combined, are most often used in presenting research findings: hypothetical, typically in the empirical sciences, and analytical, most often in the social sciences. Hypothetical methods involve setting up a hypothesis that is tested and confirmed or rejected according to the results obtained, while analytical ones focus on understanding the cause and effect relationships between two or more variables. For example, empirical science researchers can make the following hypothesis. Each new version of the software will introduce new programming errors or bugs that will manifest themselves in software malfunctions or defects. The researcher will collect data on reported software defects to prove the claim and determine whether the hypothesis claim is confirmed. On the other hand, a researcher from the social sciences might be more interested in the cause and effect relationship between software malfunctions and increased business costs. Regardless of the methodology, presenting the research findings depends on the conducted studies, and it can be experimental, qualitative, or quantitative. A crucial part of reporting in experimental studies are tables and figures with the obtained results, and the text serves for their introductory presentation and subsequent commentary on what they show. The researcher from the previous example would probably measure the time distribution of defects in the software tabular and graphically, and thus prove his hypothesis. Quantitative studies are based on statistical indicators through which significant trends, differences, and comparisons are observed. After proving the hypothesis, the researcher from the previous example might come to an additional conclusion and determine that measure software defect distributions have the same shape. He would review the trend of past distributions and guess what will happen in the future. Qualitative studies deal with phenomena that are difficult or impossible to quantify mathematically, such as beliefs, meanings, attributes, and symbols. So the research results are primarily descriptive, and the text must be understandable and clearly structured. For example, such an approach would be appropriate for psychological research on the types of stress that developers suffer from for fear of making mistakes. A story is developed to discuss the research findings observed on the obtained data. Initially, it is necessary to connect the obtained results with what was intended to be found out. If a hypothesis was set, it is necessary to say whether it was confirmed and how. If it is refuted or partially confirmed, explanations must also be given. It is also necessary to comment on whether something additional may have been learned about the initial scope of the research. During the discussion of the research findings, it is necessary to use the so-called cautious language that evokes how confident the researcher is in his claims. This kind of language allows the researcher to distance himself from the claim or data he received in the research. Furthermore, if some scale were used, from weaker to stronger, claims could be expressed as conditional, moderate, and strong. The conditional statement could begin with, "It can be said that." A moderate statement could be formulated as, "Results suggest a conclusion," and a strong statement with, "It is certain that," or "It is clear that." For example, we will hardly find a sentence in the scientific literature, "Non-smoking reduces the risk of lung cancer." However, we will indeed find the following formulation. The majority of studies indicate that non-smoking contributes to lowering the risk of lung cancer. For further learning, please review the following references. Thank you for your attention.